Hello everyone. Today we will discuss serotonergic agents. Upon completion of this presentation, students are able to clear with what is meant by serotonergic agents, what is meant by serotonin first, and then the agents acts on the serotonergic receptor. This serotonin is a chemical that has wide variety of functions in the human system. It is a neurotransmitter. Sometimes it is called as happy chemical because it contributes to well-being and happiness. The serotonin is also called as 5-hydroxytryptamine. This it is a monoamine neurotransmitter. It is found in brain, bowels and blood platelets. This is the structure of this serotonin, which contains indole as a heterocyclic ring system. This is the fifth position, 1, 2, 3, 4 and 5. This 3 number carbon is substituted with ethylamine chain called as serotonin. Chemically it is called as 5-hydroxytryptamine. It is biosynthesized from tryptophan. It is an amino acid. In presence of tryptophan hydroxylase and tryptophan 5-monooxygenase, this converts into 5-hydroxytryptophan. This 5-hydroxytryptophan. Tryptophan, it is amino ethyl, and this one is acidic functional group. This hydroxy group is substituted on fifth position as called as 5-hydroxytryptophan. Then 5-hydroxytryptophan decarboxylase. Decarboxylase means carboxylic acid functional group is removed to form this what serotonin. It is called as 5-hydroxytryptamine. 5-hydroxytryptamine. I repeat again, the biosynthesis of this serotonin is also called as 5-HT, which is synthesized from this tryptophan, which is further converted into 5-hydroxytryptophan in presence of tryptophan hydroxylase. This 5-hydroxytryptophan is converted into serotonin in presence of 5-hydroxytryptamine decarboxylase enzyme. Metabolism of this serotonin. The serotonin or 5-hydroxytryptamine is converted into 5-hydroxy indole acetic acid. It is indole. This is 5-hydroxy and this one is acetic acid in presence of monoamino oxidase. This is MAO and aldehyde dehydrogenase enzyme. This metabolism of this serotonin is metabolic product of the serotonin is 5-hydroxy indole acetic acid. This is 5-HIAA. It is metabolism of serotonin. So these serotonin is why this is called as a happy chemical, because most of the agents are these agonists are used as a antidepressant, means it against depression. These are the serotonin agonists. Types of serotonin receptor: 5-HT1A, 5-HT1B, 1D, 5-HT2, 5-HT4. These are the agonists with example. One example: Buspirone, triptans, trazodone, cisapride, and these are the selective one, selective 5-HT receptor agonists. These are non-selective, ergotamine and LCD. So 5-hydroxytryptamine 1A receptor agonists are azaspirones such as buspirone, gepirone and tandospirone are 5-HT1A receptor partial agonist, marketed primarily as an anxiolytics but also as a antidepressant. Many atypical antipsychotics like aripiprazole, then clozapine, azepine, these ziprasidons are partial agonists towards 5-hydroxytryptamine 1A receptor. This is a chemical structure of buspirone, which contains this spiro ring system. How it is azaspirodecane. It is spiro means this one. This is decane. How it is 4 5? It is 1 2 3 4. This is 1 2 3 4 5. That's why it is 4 5 decane. Decane means this 4 5 9 and this one is 10. That's why it is called as a decane. It is butyl 4 pyrimidine 2 eel piperazine. This is pyrimidine ring system. Is when 1 2 eel, that's why it is 2 eel piperazine is substituted on this pyrimidine at 2 3 4 4 number, and this is first number is with butyl 1 2 3 4. This is butyl. Then azaspirodecane 7 9 dione. This is a Buspirone. This is Buspirone. It is second drug used against this 5-HT1A receptor agonist. Then ipsapirone again contains pyrimidine and piperazine as a heterocyclic ring system. Same butyl. Means these are the essential functional groups for binding purpose towards the 5-HT1A receptor, because all this contains piperazine and this one is pyrimidine as a heterocyclic ring system. Second receptor agonist is 5-HT1B triptans. Example is sumatriptane. It is well known drug. Contains indole as a basic nucleus. Again, this third number is substituted with ethyl amino dimethyl amino, then ethyl indole 1 2 3 4 5 eel. It is N-methyl methane sulfonamide. It is N-methyl. It is methyl N-methyl, and this is methane sulfonamide. Sumatriptane. Then zolmitriptan, then rizatriptan. This is S configuration. Again, this one is indole. This is also indole, because indole is heterocycle is required for this. Dimethyl ethanes are again important for this biological activity. 5-HT2A, 2E and 5-H3 agonist 2-methyl 5-hydroxytryptamine. This is 2-methyl 1 2 3 4 5 5-methyl 2-methyl 5-hydroxytryptamine. Then 5-HT4 cisapride is an example of agonist against 5-HT4 agonist. Then next one is dazopride and metoclopramide. These two examples are agonists towards this 5-HT4 receptor or serotonergic receptor number 4, dazopride and metoclopramide. Similarity is this whole structure up to this amino. This is ethyl functional group with this replacement. It is also biologically active. Heterocyclic ring. Monoamine oxidase inhibitors. These are also increases the uptake of, or it increases the level of serotonin. This class drug inhibit the activity of one or both monoamine oxidase enzyme A and B. It is well known as a powerful antidepressant as well as effective therapeutic agents for panic disorder and social phobia. These are divided into non-selective, selective and selective MAO-B inhibitor A inhibitors. Example, hydrazines, non-hydrazines. Then these are the examples. This will be discussed in antidepressant chapter. Then serotonin blockers. This when these drugs monoamino oxidase inhibitors are, in case of this metabolism part, when this monoamino oxidase is an enzyme which is responsible for this conversion of serotonin into, or it metabolize, the metabolic product is 5-hydroxyindole acetic acid. When these inhibitors inhibit this enzyme, leads to increases the level of the serotonin, isn't it? That's why these agents are antidepressant agents. Means when it increases the level of what this serotonin. That's why these are antidepressant. These are selective MAO A and MAO B. There are two MAO, monoamino oxidase A inhibitors and B inhibitors. Then last part is serotonin blockers. This block the serotonin receptor in GI tract, CTZ and BC, used for nausea, vomiting in patients receiving chemotherapy, chemoreceptor trigger zone, and this positive post-operative nausea and vomiting. Examples are dolsatran, then ondansetron, granisterone and palonosterone. These are the examples of serotonin blockers. Means it blocks the serotonin. These are the structures of serotonin blockers: granisterone, dolsterone, ondansetron, palonosterone. This is regarding serotonergic agents. Thank you.